This was easier than last week.
Yeah, this was easier.
Yeah, last week was confusing.
I feel like the second part of the week is always like harder
I
than
know.
the first part.
It's because it like builds on the other lesson. So, yeah.
So you got all the preparation figured out?
Yes,
Preparation.
the only thing I was kind of confused on was how to tell what the graph was going to look like based off of the information that you got.
Oh yeah, like normally
Yeah, if it was
distribute.
a bell shape or whatever.
Yeah.
That was it. Like, I understood how to do the math, but
Yeah, I think it confused me when he did the um like the chart thing, like on the video, he had the graph thing, and then like it was like right skewed, and then it turned to bell shape.
yeah,
That's what confused me.
that was weird. I think it altered the numbers. I think that's Catherine.
Yeah.
Okay, I'm always confused because I have the group conversation, but I don't know who's who.
I know. I didn't add anyone's phone number. All right. So yeah, but other than that, it's like it's um, the graph is normal when the population is normally distributed or the sample size is large. But what it confused me because I don't know what's considered large,
Yeah,
but I think it'll tell you in the question, hopefully.
yeah. My numbers. I had a mean of what was it? 142,736.
Oh yeah. Um, I
I guess that
have.
was unusual because it was
Where's that?
the weird side of it.
Oh, I had one. I had 40. You're talking about question 7, right?
Yeah.
Or wait, no. Yeah. I had 43,240. Um, let's see. Did she send me her email? Okay, let me invite her.
Okay.
Okay. Address 621. Okay. And while she's coming on, um, I'm gonna go lay my daughter back down. She's been only asleep for like 30 minutes, so
Okay. Sounds good.
be right back.
Mhm.
Okay. Um, oh yeah. Okay, so Mine was, I felt like, was pretty unusual too, because it's cut off of the graph. Like it was in the, but I think it's to show us that we only had one piece of data.
Yeah.
So that's why it wasn't.
If we did it more, it would look like what that graph is, I guess.
So, do you want to start the homework quiz, or should we wait for Catherine?
I guess we could get it going and at least have it open.
Yeah.
Because it's unlimited time, so it's not like.
All right.
Okay. Hopefully this one's not like billions of questions. 12. Okay.
That's not too bad.
Well, the first two don't really count.
Hi guys.
Hi.
I went to bed super late and I forgot to set my alarm.
That's okay.
Sorry. I heard all the dinging and I'm like, what is that? Okay.
We just opened up the homework quiz. We haven't started yet. If you want to.
Oh, you guys didn't go over the part 2?
The what?
You guys didn't do the part 2?
Yeah, we did.
Oh. Okay,
Did you have any questions about it?
Yeah, I didn't understand it at all. I'm completely lost, so.
Oh.
So, did you randomly select 5 of the 30 salaries? Number 7.
Yeah, I think what I had a problem with, I think that wasn't it. Hold on. I got the answer right. Hold on. I need to go back over it. I think what I'm not getting is the mean is easy and all ours would be different.
Yeah.
Is the normal distributed and that, like, if we don't have the shape or whatever, then I don't understand how it'd be normal or not.
You look at the graph that's on the sheet.
Yeah.
And then pinpoint on there where your mean would be. And then depending on where it is, you're supposed to state whether or not it's unusual.
Okay. Yeah, mine's not. Was your guys's?
No. So I think it's because we only had one sample size because it was only for ourselves. So it's going to be unusual, but the larger sample size, it'll be more normal.
Yep.
So your guys's was not normal?
No.
Well, what does normal mean?
The closer to the median.
Yeah. Like my number was 43,240. So it was kind of off to the left of the graph.
Well, mine was 45,000.
Oh, that's pretty close.
Yeah.
So wouldn't that be normal?
Yeah.
Oh. Normal is close to the mean then.
Yeah.
Okay. I think that's
average. So
that's what I really didn't get in this homework is the definitions of them, like as the sample size increases and becomes large, the distribution of the sample mean becomes approximate normal. I'm completely lost when I don't understand what that's saying.
So basically, if you were to flip a heads and tails on a coin, you have a 50-50 chance of getting it. But when you're actually flipping the coin, you might end up getting a bunch of heads in the row instead of the 50-50 tails. So the more you flip the coin, the closer you're going to get to the 50-50 heads and tails. So that's basically the more times you take the problem, the closer it's going to get to the actual probability.
So what's the difference between a sample mean and the population mean?
The sample mean is like what you just did.
They gave me the sample?
Like what you did, you took 5 things and then found the mean of it. So that's one sample. The population mean is like out of all those samples that you had, it's the mean of that.
Oh, okay.
So that's kind of where the graph points to, like whatever the mean of the population is, that's where it's gonna kind of slope towards.
Oh, I see. So the graph is all those put together.
Mm-hmm.
Okay. Okay, well, I guess that makes more sense. And then the law of large numbers is as the sample size increases, the sample mean draws closer to the population mean.
Yeah, that's like the heads and coins thing that I was talking about.
So what's the difference between those two? The central limit theorem and the law of large numbers, aren't they both saying that they get closer?
Yes.
So the difference is in the law of large numbers. The standard deviation of the sample mean will get smaller as the sample size increases. It's like focusing more on the accuracy and the.
Yeah, I have accuracy on one and normal on the other. Right? One means normal and the other one's like accuracy or whatever.
Mm-hmm.
Yeah, it becomes approximately like normally normal.
Okay.
It's confusing.
Yeah, it was confusing. I mean, I'm still trying to grasp the whole distribution and some of the other words that we have, like the mean of the distribution of sample mean equals the mean of the parent population. Like, I can't even grasp what that means. It's driving me crazy.
I know.
So,
I write it down and then I just have to keep looking back at my notes and.
Yeah, that's what I'm gonna have to do too, because I don't know. I just don't get it. So, okay, so you guys said you already started it?
We
haven't.
Going to.
We just opened it up.
Okay. All right.
So, looking at question 3.
Mm-hmm.
I'm like already like, crap, what am I supposed to do?
I know.
Okay, when calculating anything, round numbers. Okay. When you are taking a sample size of 5, what is the shape of the distribution of means? Distribution of means. I don't even know what that means.
Like that's like where it all lays.
So distribution of means histogram when the parent population is skewed right. Yeah, I don't even know what that means.
So, it's right skewed, so it's not normal to begin with. So, we have to look at the distribution of sample means was not normal. And then
So the sample size is small. It's going to be the right skewed one, right?
yeah, would you consider that small? I think that's small.
Well, 5, because I'm just thinking about the videos that he had where he was clicking the little button,
Yeah, that's what I was thinking.
and when
Well,
he
it says
it was.
what? Oh, go ahead.
No, I'm done.
What were you saying?
I was just talking about the video. When he had the 5 samples, it was all on the right skewed side of it.
Okay. So what's the answer?
I think
Right
it's
skewed.
right. Yeah, skewed right. Because if that number was large, like if that number was 100, it would be normal. But
Yep.
5 is considered small, then it's just right skewed.
Mm-hmm.
Okay.
So that answers the next question too, then.
Oh, yeah.
Yeah.
So that one would be normal. It's just hard because, like, I don't know where it goes from being small to considered being large.
I know.
But
Well, then in the video he said like, or maybe it's not in the video. I was reading all the text too. Like 50 was large or 25 was large or something. I don't think it takes that many to be large. Okay, so when you are taking a sample size of 5, what is the shape of the histogram in the parent population is normally distribution?
Isn't
that'd
that
be normal.
normal? Yeah.
And why would it be normal?
Because
Because
it's already normally distributed.
Yeah, so when you're making a histogram, it's either going to be left skewed, right skewed, or normal to begin with.
okay.
And it'll tell you in the problem, like the first one was right skewed, so that means that it's not normal to begin with.
Mm-hmm.
So then you have to look at the sample size. If the sample size is large, it'll be normal. If it's not large, it'll be not normal. But then if you have a histogram that's already normal, it doesn't matter what the sample size is, it's going to be normal regardless.
Yeah, it's gonna stay that way.
Does that make more sense?
Yeah, I was drawing the other thing instead of the histogram just now. So so if there's only 5, it would go up like this way, up to the middle and then down. Because it's normal and there's only 5 samples, right?
For
You see what I'm saying?
on question 5, is that what you're talking about?
Yeah. Like if there's only 5, then the histogram would, and it's normal. So like the third number would be in the middle. It would go up, down, it'd be even, right? The histogram would just go up like that.
Yeah.
Yeah, it's like a symmetrical.
Okay.
So the next one, when you are taking a sample size of 100, was the shape of the distribution means when it's normally distributed, and that would still be normal.
These questions seem obvious. Is it supposed to be that easy?
Yeah, I think they're easy questions.
All right. When would the distribution of means be normally distributed?
Okay. Yeah. I mean, I'm sorry, but I mean, when would the distribution of means be normally distributed?
So bell shaped.
Oh, because it's normal.
Yeah.
But isn't a mean just one number?
Yes. So distribution of means is multiple means.
Because you're taking a sample of the means. Like you're not doing all of them together and just coming up with one. You're taking like a sample of it, like what we did in the preparation.
Mm-hmm. Okay. Oh, I see. It gives us all the means, and then are distributed.
Yeah.
So if they're normally distributed like this, right? Data are drawn from a population that is normally distributed in the sample size system.
So do you know that this one, like, does this make sense to you?
Okay, well, if it says normally distributed, then it's not going to be skewed right, right? It's not the bottom two?
It's only, you have to look, if it's right or left skewed, you have to look at the sample size.
Mm-hmm.
And if the sample size is large, then it'll be normal. So the bottom one is also true.
So the only one that's wrong would be the third one.
Oh, I didn't see that it said choose all that's correct. Okay. So when the data are, okay. All right, I'll just go back over this when we're done.
Did you watch the videos?
Yeah. And I just,
Because those
You
are
sound
usually what help me
last week.
more.
I was just, I still get confused with the distribution to me. Distribution is just putting them on a graph, distributing them on a graph.
Yep.
Putting them on a graph. So putting the means
On a histogram graph.
on a histogram. So putting the means on a histogram, normally putting them on there means they're even.
Yeah.
Right.
I know, I
My
think you're
brain
thinking about it too hard.
I know,
Yeah.
I am, because the word distributed just, it throws me, and I am thinking about it too hard. So, yeah, okay. I'll grasp my brain in a minute. Okay, which of the following best describes the explanation of the theorem? Well, I have that right here. So, when the sample size is large, their distributed means are normal. It's parent population, and the sample mean will follow enormous. If the sample size is large, then the sample size is large, the shape of the distribution of sample means will be apart. Is it the bottom one?
They're all right except the third one.
Can't we only click one?
We only click one though.
When would the distribution?
Oh, it's the best explanation.
Which of the following gives the best explanation? Wouldn't it be the bottom one?
That's what I'd
Why
say.
did I say that? Oh, you're on 8. I thought we were still on 7.
Oh.
I was confused. I was like, okay.
Oh, yeah. Sorry.
We moved on. Okay. Yeah, the bottom one.
Okay. Because it's saying as the sample size gets larger, the distribution of the sample means is approximately. That's exactly what I have written down. So,
Yep.
Yeah.
okay.
All right. Now I know where we're at. Okay.
That's all right. We kind of jumped forward after we said that.
Okay. So let x be a random variable with the population mean of 10 and the standard deviation of 6. Suppose the sample size is 36 is drawn from its population. So this one,
The mean.
what is the mean? Is that 10?
Yeah.
And the deviation is 6. I like it when they give us the answers.
Well, no, you have to do the formula, I'm pretty sure, for this one. Because it's the standard. It's
yeah,
the
but the mean doesn't the
distribution.
mean stay?
Oh yeah, the mean's fine. I'm talking about question 10.
Yeah, the mean stays. And then
for question 10, you have to do that little.
yeah, don't you do 6 divided by the square root of 36?
Yeah.
So that's 1.
Yeah.
I don't know why I knew that in my head. Right. if the sample size is large, what would be the shape? Normal.
Yeah, because it's saying that because our n is 36, so it's large.
Mm-hmm.
So when it says regardless of the distribution of the population, so what does that mean?
That means like right skewed or left skewed or normal to start with.
Mm-hmm.
Oh, now distribution means right skewed or left skewed. Okay.
Because that's like what your histogram is. Like once you put the means on and you draw your histogram, depending on what that shape is, if the sample size is large, what would the shape be?
It'd be normal, right?
Mm-hmm.
Yeah.
Yes. So what theorem would justify a response? Isn't that the central limit theorem?
Yeah.
Okay. I guess we'll see how we did.
Yeah.
We only get one attempt at this one, so.
I'll submit it.
Well, we got 100%. Yay.
Yay. All right. I'm going to go back over mine and try to understand it a little bit better.
Okay.
Okay. Let us know if you
All
have questions.
Yeah.
Yeah, I'll just go over the video. And like you said, it's just I need a little bit more time.
I found it helpful. I just like write down the important stuff and I'll just like look through it as I'm doing the problems and it like kind of just clicks because you're looking and doing it and looking and doing it.
Yeah.
Some examples and stuff.
Yeah. All right. Okay. So Thursday.
Great. Sounds
All
great.
right. See you guys later.
All right. See ya.
Okay.
Bye.
Bye.